Alright guys, so today I'm going to go over some necessary things you need to know that you're probably having some questions on, and most of what that is doing absolute and apparent magnitude, and then using these to actually figure out how far away something is from where you are. So we're going to start off with a review of apparent magnitude and how you solve those kinds of problems. So let's start with apparent magnitude. I'm going to have a couple examples for you guys. So let's start with this one, number 1. We have star A. We have apparent magnitude is plus 1. And it is 6.25 times brighter than star B. Okay, so we need to figure out the apparent magnitude of B. So the first thing here that we need to look at is the fact that it says A is brighter than B. That means A needs to have a smaller number than B. Okay? When you are the brighter star, you have the smaller number. The smaller the number, the brighter the star is. Okay? Same thing with luminosity when you have absolute magnitude. The smaller, the more energy it's giving off. Okay? So let's start with that. So the second thing we need to look at is how many times brighter it is. It is 6.25 times brighter. Alright, so we know that it is 6.25 times brighter. So if we go over here to difference in brightness, we can find 6.25 and we go to the left and we see that means 6.25 is equal to 2.5 to the second power. Okay? And that power is what that is important because that means the difference in magnitude is 2. Okay? And since A is brighter, that means we add 2 to 1, which gives us positive 3. And so that makes the apparent magnitude of B positive 3. All right. So let's try this again. With a different example. So let's try a second one. Okay, star A has an apparent magnitude of plus 3. It is 16 times dimmer, in this case we are using dimmer, than B. Okay? So if A is dimmer, that means star B has to be the smaller number. So now let's try to find for star B. Okay, so in this case we have, 16 times dimmer, that's the difference in brightness. So if we move over to the left, we see that that means it is 2.5 to the third, which means our difference in magnitude is then 3. Okay, and since A is dimmer than B, we have to subtract A from what we found here. So we do plus 3 minus 3, and that gives us an apparent magnitude of 0. Okay. What you need to remember for apparent magnitude and for absolute magnitude is that you can go into the negative numbers. This is okay, because the smaller the number means it could go into the negatives. We have stars that have an apparent or absolute magnitude of minus 4, and I think all the way up to like minus 6. It happens, okay? That means they're just extremely bright or extremely luminous, okay? In this case, our star has an apparent magnitude of 0, which means it is brighter than star A. It is much brighter. Okay, so let's try again. Alright, let's try another one. So in this case, we have star A has an apparent magnitude of plus 1. Okay, and it is 40 times brighter than B. Okay, so in this case, again, we are going to be adding the number because B needs to have a bigger number this time. Okay, and we're trying to find star B. Apparent magnitude is what? Alright, so let's start with 40. If we look at our chart, 40 is equal to 2.5 to the fourth power. Okay, and that's the important number. That's our difference in magnitude. Okay, which means our magnitude difference is 4. In this case, we're going to do plus 1 plus 4, which means we have an apparent magnitude of plus 5, because it needs to be the bigger number in order to be dimmer than A. Alright. Now let's do a bigger one. These happen. Okay. Let's do star A has an apparent magnitude of +5, but it is 10,000 times dimmer this time. 10,000 times dimmer. 10,000 is nowhere on this chart. Okay? And that's important. In order to do this, we have to break 10,000 down. So we break 10,000 down into two parts. What times what is 10,000? 100 times 100. Done. Well, that's on our chart. That means we are going to have 2.5 to the 5th times 2.5 to the 5th. Okay, that means we have 5 twice. And what happens when you multiply exponents? You add them. 5 plus 5 is equal to 10. In this case, that is our difference in brightness. Okay, and since B is going to be brighter than A because A is dimmer, we need to subtract. And in this case, we're going to subtract what we have by the difference in brightness. Okay, and that's going to give us -5. Alright? Why did we do it this way? Remember, negatives are possible, but let's say that we did 10 minus 5. We would equal 5, which is the same as A, which means they're the same. And that doesn't make any sense, because A is 10,000 times dimmer than B. So we have to do it this way. And that's how we get our apparent magnitude of -5. Okay? Alright, let's try another one. Same thing. Star A is equal to +3, and it is 160,000 times dimmer. Okay, this is our difference in brightness again. Okay, star B is what we need to find out. Again, 160,000 is not on our chart, so we need to break it down. What times what is going to be 160,000? Well, let's think about that. Well, 100 times 100 times 16, right? 100 times 100, because that's going to equal 100,000, times 16 will actually give us 160,000, believe it or not. Well, what do each of these come to when we put them in exponential form? Okay, because again, those are on here. Now we have to move over to here. Well, that's going to be 2.5 to the 5th times 2.5 to the 5th times 2.5 to the 3rd. Okay, because 16, 2.5 to the 3rd, 100, 2.5 to the 5th. Okay? Cool. Alright, so what we will be using here is then 5 plus 5 plus 3. What is 5 plus 5 plus 3? 13. That is our difference in magnitude. 13. Okay? And again, A is dimmer, so we have to do +3 minus 13. That's going to give us a -10. That's a very, very bright star, if we were to think about it in those terms. Okay? Does this make sense to everybody, I hope? Alright. And now we're going to move on to absolute magnitude. And so I'm going to stop this video, and this is going to be it. And our next video, we're going to go over absolute magnitude.